It's a bit chilling today. Ah!
Ready?
Yeah.
Okay, go.
Brain.
Juice. Yes.
Brain.
Juice.
Yes! Oh, this is gonna be so good! What?
To answer the question, we need to understand first how black holes are created. It all begins with a cloud of gas and dust swirling in the cosmic soup. Some regions of the nebula begins to contract under the effect of gravity. As the cloud squeezes tighter, its core gets hotter and denser. Then, a protostar is born, a baby taking its first breath. Give it enough time, and the temperature would rise enough so that when the hydrogen atoms collide, something different happens. A nuclear fusion of hydrogen atoms that gives helium. Congrats! Here's a star. This nuclear fusion is what gives the star its heat, energy, and light. It will, for the next millions of years, be the fuel for the star. Now, do you remember the effect of gravity that made this gaseous contract? It could act at them at first, but once nuclear fusion starts and release an enormous amount of energy, this energy creates an outward pressure that contracts the inward pull of gravity. So the star stays stable by maintaining a balance between the inward force of gravity and the outward pressure from the nuclear fusion. As long as the star has the fuel to balance this gravity force, it lives. Until the hydrogen fuel has been consumed, and it's time for the star to rest in peace. Its time here has come to an end. The core of the star collapses under the effect of gravity. The outer layers of the star are then expelled in a massive explosion, the supernova. Now, what happens to the star after its death depends on its mass. As the mass of the star is bigger, the gravity will crush it into a smaller volume. We're only gonna discuss the case where the core's mass is massive enough that the gravity will become so intense. In this case, the core collapses further, forming a singularity, a point of an infinite density surrounded by an event horizon. That's what we call a black hole. The event horizon is the boundary beyond which nothing, not even light, can escape. The black hole's gravity pulls anything that crosses the event horizon, and it is forever trapped. But why? Why do black holes do this? Are they an evil star who's mad at the universe about its death? It decides it will get revenge and destroy everything. No. So basically, a little bit of classical physics. The distance between two objects affects their gravitational interaction. If you wanted to calculate this force, you have to consider the distance between their centers of gravity. So, if we put a star and a planet, let them pull each other, supposing that the planet won't turn into a KFC, at the end, they will touch, but we will still have a big distance between their centers. This is not the maximum gravity force we can get. Now, take the same star, decrease its volume. What will happen now? The planet will move closer and closer and closer, and the distance will decrease and decrease, and the gravity will increase and increase. It will become so enormous because of how much you can minimize the distance. Yes, the star still has the same mass, and since gravity depends on mass, it still has the same gravitational field. But can you see now how much you can minimize the distance between their centers? Now, back to our question. What will happen if our sun become a black hole? Well, our sun doesn't have the enough mass to become a black hole. It will never be a black hole. But let's just suppose that, hypothetically, it did. What will happen to us? Well, nothing. I mean, other than the fact that we will freeze to death. But if our sun suddenly become a black hole with the same mass as it has today, this would not affect the orbits of the planets, because its gravitational influence on the solar system would be the same. A solar mass black hole would exert no more gravitational pull than our sun. The secret to the black holes is not that they have more gravity. It's only when you are very close to them that black holes behave differently than other massive objects. So, as long as we are not in the event horizon, the point of no return, we are safe. The planets would continue on their orbits as if nothing happened. So we're good, right? We just need to find a solution for our freezing and darkness problem.